When someone receives a head injury that is obvious to our eyes, it is much easier to understand how that damage can impact their functioning, thoughts, and behavior. But when the injury is not visible, it becomes difficult for most people to accept that it can be responsible for physical and behavioral consequences. The main reason for this is it is difficult to visualize the impact of brain injuries, even mild ones, without an understanding of how fragile the brain really is, how it can be injured in numerous ways, and how the brain and body respond to those injuries. Even though it is resilient due to its high fat and water content, the brain can literally be pulled apart like bread dough. This design is perfect for average movement, but not excessive force. Even just lightly tugging on the tissue a few times will cause it to break down easily. This is why the brain is not designed for massive and repeated impacts. It is also why it is so vulnerable to heat, radiation, chemicals, and malnutrition. As a result of the brain's design, a common injury with high-impact trauma is called coup and contre-coup. This occurs when the brain continues its motion into the wall of the skull and rebounds or reflects into another part of the wall from impact forces. It has been estimated that a car crash into a solid object at just over 20 miles per hour, and even hard hits in sports such as football, boxing, and even cycling can cause such injuries. This is a major component of shaken baby syndrome, an injury caused when an infant is shaken violently and repeatedly, usually out of frustration or anger. Depending on the impact forces affecting the brain, coup and contre-coup may result in diffuse axonal injury, hemorrhages, hematomas, encephalitis, cell death, and more. Diffuse axonal injury is basically the shearing or tearing of axons, the nerve fibers that transport messages from one neuron to another. It is estimated there are between 80 and 100 billion neurons that form the biological circuitry in an adult human brain. Since the brain creates its reasoning and reactions based on communication with all the affected neurons, if any of those neurons cannot communicate suddenly, there is going to be a problem. The brain will know something is not right, but it may produce unusual results and not know why, or how to solve it. What if the loss of complete and accurate communication within the brain resulted in the brain developing a different meaning from past experiences? What if experiences and information stored in a part of the brain were no longer accessible? What if it affected the ability to remember, adapt, problem solve, or determine correlations? How frustrating would it be if your brain couldn't do what you know it could do before, but you didn't know why? What if those damaged axons were the gatekeepers to emotional control or stopping aggressive and violent behaviors? Think of a computer that has a corrupted file or virus that causes it to produce inaccurate or harmful results, or even crash under certain circumstances. A substantial brain injury, or even repeated mild injuries, can also trigger secondary injuries that can cause deterioration over time. Cell death and damage, inflammation, and changes in biochemical and electrochemical processes are elements that can create conditions ripe for tissue breakdown and mutations in cell division, especially in an area that has been damaged before. This can show up as chronic traumatic encephalopathy, and some research suggests possible tumor development. When inflammation is prolonged, the chemicals that flood into the injury site in response can potentially contribute to oncogenesis due to their mutagenic properties. And it is not only neurons that can be damaged by impact trauma events. Healthy communication between neurons and the brain and body are made possible by support systems, special structures, and electrical and chemical processes that can be damaged from trauma impacts too. A healthy brain has mechanisms that help keep the system in balance. If any of them are damaged, balance may not be possible. Excessive or insufficient hormones or neurotransmitters can throw emotions, thoughts, reasoning, and function all out of whack. Visualizing brain injuries can also be challenging because no two brain injuries are the same. Someone may have a visible injury so severe that survival may be in question, but then go on to live a relatively normal life. Another person may be negatively impacted long term from a brain injury from simply falling and hitting their head, or being assaulted with only one punch to the head. Often, it takes time for the consequences of a brain injury to surface as well, compounding the issue. With all these challenges, it is easy to see why traumatic brain injury has been called the invisible disability and the silent epidemic. In the past couple of decades, however, traumatic brain injury has found its way more into mainstream conversation, unfortunately, most often because of high-profile, tragic events. In the next episode, we will examine how the brain and body work together to regulate functioning and how a traumatic brain injury, and even multiple injuries, can affect that relationship.